lines, and you just call this particular. I can simply say that whatever fruit is occurring on this side, you just called it A, and the group this on the higher towards the right of your number line, it is you just called it group B. Okay, and now you could also call it otherwise. It doesn't matter whether it is B or A or A or B. You can just call it whatever, because we are not sticking to a particular type of fruit. Okay, so it is very clear that the group A has smaller diameter, or I can say they are smaller in size. It is pretty much visible that whatever is this A fruit, it is smaller in size as compared to my B fruit, right? So now the question comes that this was that now if I give you a new fruit whose diameter it lies somewhere around here. This is your new fruit. Like I am giving you the diameter of a new fruit and it lies somewhere around here. Right? This is the diameter, say around 4.8. Right? The diameter of this particular fruit is 4.8. Then how you are going to categorize? So you want to predict the category of the new fruit. So looking at this data, what will be your prediction if I ask you? So I am seeing that this particular new fruit is lying closer to my group A people, group A sample fruits, right? So a person like me, if I would have seen this, I would classify this as A, right? Similarly, if I had a new fruit which had its diameter somewhere around here, so I would classify it as or categorize it as fruit B, that this fruit is of type B. Okay. Now it is quite possible that your measurement, the new fruit could have been here. Okay. What you are going to do when your fruit is the new fruit is here? Then again you will see that what are the other fruits lying closer to this new one. See that the diameter of you are going to see you are going to look at in the proximity of this new fruit and check out the category of those fruit. If the category of the fruits which are lying in the proximity of this new fruit, you are going to categorize this one as that whatever is the majority says. For example, like in this case, you are going to say that this new fruit is lying closer to the group A. So again, you will try to say, okay, I'm gonna call it group A fruit. Similarly, if you had a fruit somewhere here, so again you're gonna say that it is lying closer to the group B fruit. So I will classify this as I will categorize it as group B. Okay. So let's now bring out our learn some terminologies, ML terminologies. So this container of fruits that I have given you, right, and along with its its category too. Okay, so this container, this is nothing but your training data. A training data is nothing but this is a group of examples or samples, or you say fruits whose category you know. Okay, you will see, and this is your training data. Okay, and these fruits, these dots that you are seeing, these are nothing but your sample points. Sample points, you will also hear terms like data points. You will also hear entity, and you will also hear something like instance. Okay, these are multiple names through which you call a entity or these dots in this example. In this particular example, this diameter, which is giving me some kind of information about my entity, this is nothing but my feature. Okay, and this category of the fruits, this is nothing but we call them, rather than calling them as group A or group B, but we call them as class A. We call them class and class B, right? And the new point on which we are trying to make a prediction, this is nothing but my test data or test point. The one in the yellow, it is my test data. A test data is something whose feature value is known, but we do not know its category. Okay, so we have to predict the category. We only know the feature value of the test data or test point. Test data or test point, right? And so in this particular example, the number of features that we took was one, right? The number of features just one. So we could draw those features, we could visualize those features onto a number line, right? If I have just one thing to show, then I can simply plot it on a number line, right? So just for one feature, I can just use a number line to visualize it. Similarly, if I had two features, for example, in the fruit example, I could measure the size, meaning diameter. I could also measure the weight of the fruit using some weighing machine, right? So if I had two features corresponding to every fruit, then to visualize it, I might be needing a graph like this. So on the x-axis, I could have plotted the diameter of my fruit, and on the y-axis, I could have plotted the weight of my fruit, right? And if I just take these fruits here, and this is my diameter, and this point is nothing but my origin, then the collection of in this case, what I will observe that some of my fruits are lying somewhere around here. Since diameter of my group Since diameter of my group A class was smaller, so I expect them to be nearer to the origin. And since diameter is small, I also expect उनका weight भी small होगा, right? Similarly, the group B, so I expect the group A to be somewhere around here. Similarly, group B fruit, I expect them to be somewhere around here. Since they are greater in size, and since they are greater, so I expect their weight to be larger. Right? So this was a case that if I had two features. Similarly, if I had three features, I could visualize it. If I had three features, for example, I could have weight, I could have the size, and I could also if I had given you the vision capability, then you could also see the color of that particular fruit, right? So in that case, you have three features, and to visualize it, you can just we can draw a 3D plot, right? In 3D plot, we have x, we have y, and z is pointing out, you know. So if this is my x and y plane, so that is something along the vertical, right? So I could visualize it like here, this. But if I had say four features, then there is no, we cannot really visualize things which are beyond, because our entire world is 3D and we do not know how things look in four dimensions, right? So these features are also known as dimensions, because they are determining, the space, right? This is the space. For example, if I have two features, then I can just plot all my points onto a 2D space, right? So this is nothing but a two-dimensional space. If I had 3D, three features, then I can visualize my points or visualize my data in 3D space, meaning three-dimensional space. Similarly, if I have four features, then I will be requiring some four-dimension space. And similarly, if I have, n number of features, then I will be requiring some n-dimensional space, right? So, as I was saying that in the training data, we know what we are given is, we know the features, meaning we know the feature values as well as the true category. For example, if I pick this A fruit, I know that this fruit is A, and then I am also given the diameter of this corresponding fruit. So I can simply plot it. Similarly, when I have this B fruit, so I know its feature value, meaning I know its diameter value, as well as I know its true category, which is B. Okay. So in training data, I am given the feature as well as the classification or the class of my fruit or the true category of my fruit. In the test point, I am just given the feature value. I have to predict the category, right? So in KNN, like we solve for this example, what we try to do is, as I was saying that we try to look at the category of the points which are lying closer to the new data point. For example, when I said that if this is my new data point, then I'm trying to see that what is the category of the data points which are lying closer to this new point. So what in KNN, what we do is we try to find out the closest near points, closest key points, K. For example, you could get say 10 closest fruits, right? So we are just keeping it variable. So we are saying that we are finding out closest K points. Then we check out the category of those K points. Category of the K points. So if I take K is equal to 10, and out of those 10 fruits, 6 are saying that their category is A, and 4 are saying that their category is B, then my answer is going to be the majority, the max. Majority means the whatever is my majority vote. Okay, so in this case, since the number of samples or the number of data points of A category is more, is going to be A. Similarly, if I had taken K to be 20, and out of 20, say 11 are not 11, say 18 are saying that my category is B, and only 2 are saying that my category is A. Then again, since we have 18 fruits category is B, so I am going to take the opinion of the majority, and I am going to make my prediction to be B. And what is the confidence? With what confidence I can say that the new fruit has a category B? By confidence of 18 by 20, meaning out of 20 nearest fruits, 18 are saying that they belong to me, right? So my confidence will be 0.9%, right? With 90% confidence or 0.9% probability, I can say that the new fruit is going to be of B category, right? Similarly, if in this case equal to 10 example, it was quite possible that that out of the 10 fruits, 5 are saying my category is A, and 5 are saying that my category is B. Then there is a 50-50% chance that my model will say with a 50% confidence that this fruit is of type B or this fruit is of type A, right? So here I could say it with a 50% confidence. Okay, so this is this is really the algorithm. So now let's jump into coding this. I hope this was clear that we are in KNN we try to predict the category based on the what are the closest points based on the category of my k nearest point, and therefore KNN is nothing but k nearest neighbor. Okay, KNN is nothing but k nearest neighbor. So let's now get to implementing this. I'm going to use Colab, Google Colab. Google Colab is a virtual machine which is provided by Google, right? So it gives you processing power, RAM, some storage. So if you have a Gmail account, a Google account, then you can go on to uh, creating a Colab notebook. It is sort of similar to your Jupyter notebook. So on Google Colab, all the requisite softwares like it has Python installed and some of the important packages like NumPy and we are going to see NumPy and SQL and all those packages are pre-installed. Okay, we need not install it externally onto our laptops. It is already present there. So this is a Colab notebook. So here you can just rename it. Right? Just give it any name. So to code this particular algorithm, we are going to be using the NumPy package. So NumPy, a package is nothing but a collection of files, .py files, in which it gives us pre-built functions. There are multiple functions which we can straight away use. So to use any kind of package, first we need to import it in our file. So this is a code cell wherein you can write your Python code, right? So first of all, we are going to be importing the necessary packages. So one of the necessary packages is NumPy. So NumPy is used for numerical computation. It is very powerful and as NP. So rather than calling the NumPy package as NumPy, we are going to give it an alias, which is NP, like short form. So what happens is, think of this NumPy package as a folder, and it has multiple .py files. So it could be f1.py, f2.py, f3.py, right? Right? It has multiple. These .py files are nothing but modules. And these modules, in this module, we have functions, multiple functions. So if this is your NumPy package and this is your module, and you want to say access some function 1 inside your f1 module. So how you can access it? You will have to write np dot the name of the module, which is f1 dot func 1. This is how you are going to access this if you want to use this function. For example, say this function finds the factorial of a number, right? So if whatever is the name of the function. So if this function func1 finds the factorial and you want to just use this functionality, you don't want to get into how a factorial is computed. You just want to get the answer. You're just interested what is the input. I will just give an input and just give me the answer. Right. So the way to access is you write the name of package, then the name of module, and then the name of function. Okay. So rather than typing the entire full name like NumPy, when I am just giving NumPy an alias which is NP. Okay. So I am importing NumPy as NP. So this package is for very powerful package for numerical computation. The other one is matplotlib. Matplotlib, there is a pyplot module, and I'm giving it as an alias, which is PLT. So matplotlib is a package which is used for visualization. As I was saying here, that we can plot graphs. So for drawing graphs and stuff, and visualizing the data, we use this matplotlib package. And since we are going to be, testing our KNN model onto the digits, so we are going to be needing that the collection of handwritten digits ka data, right? So that data is available in a package which is in keras.dataset. So from keras.dataset module, what we are going to import, we are going to import the MNIST data. So this is for getting the digit data. All right. So then you can just execute a cell either by this play button, and you can also do, if you just hover over it, it will show you what you can do. So it is saying you can run this cell. Running the cell means you can execute the code inside the cell by pressing either Control plus Enter, or there is another shortcut which is Shift plus Enter. Right. So once the it has been imported successfully, you will see a sign like 1. Okay. So as I said that let's just get an example of a NumPy array, how it looks. So you must have seen arrays, right? Arrays in some sort of in any language. For example, 1, 2, 3, 4, 5. So this is an array, right? And if this is a NumPy array, for NumPy arrays also what happens is they have an index, right? So the index means the position of a particular element within a given array. So the first element has an index of 0, the second element has an index of 1, the third element is an index of 2, and similarly 3, 4, and so on, right? So array is nothing but a collection of items, and collection of items or collection of, it could be a collection of integers or characters and so on, right? So to create a NumPy array, if I just create a NumPy array, say a is equal to 1, 2, 3, 4. Okay, I have this NumPy array. Why the NumPy is so powerful is, let's just print this array first. I mean, see the content of this array. As you can see, that it has 5 elements, right? So what NumPy allows, it allows us to perform element-wise operation, right? So if I want to add, say, 2 to each of the element of my array A, so if I want to add 2 to 0th element, to first element, to third element, second element, and so on, I can simply say A plus 2. So see, so it performs an element-wise operation. So this is it, that without writing loops, it is doing this element-wise operation, right? Similarly, you can do all types of mathematical operation like this. For example, if you want to multiply, and so see, you get 2, 4, 6, 8, and similarly, if you do subtraction, so you get -1, 0. So element-wise, it is performing the operations element-wise, right? Similarly, you can also divide, right? So the beauty is that it is doing element-wise operation. And if you want to do square, so we have this double star operator, and this is also, it is performing element-wise, right? So this is the power of that without that. So since we are not writing any sort of loop, and therefore there is much less code we have to write, and debugging is also easier, right? So let's straight away jump into writing our code for KNN algorithm. So we are going to be defining a function, a predict function, which is going to, so in KNN, our agenda is to predict the category of the new point, right? So this is the format of writing a function. So first of all, we use the def keyword whenever we are defining a new functionality in Python. We use the def keyword. Then we use the name. We give the name of our function. So it could be anything. It could be Princey or get prediction, uh, recognize digit, whatever name you want to give it. I'm giving it a predict. And inside these circular brackets, we pass our arguments. So the arguments are those function are variables or variables which will which are nothing but the input to my function, right? So the input to my function in case of KNN, what I'm going to need, I am going to need the training data, right? So in machine learning, this training data, as I was showing you here, you know. So let's just, I was giving, this training data, like how will it be given to me? It will be given to me in some form of array, right? Some kind of array, or you can say some kind of tabular format. Okay. So what I'm going to have this training data, we have, the features. We have a table which in which we have the features. So if this is feature 1, this is feature 2, right? And each row within this table corresponds to an entity or the sample points, or in this example it could represent a fruit, or in a digit recognition example, since we are using image as input, so each row will be nothing but an image of a digit, image 1, image 2, just like this, right? So this is the matrix or the table or the array which only includes the feature of a particular entity. We represent it using X, right? And the corresponding, as I said, that in training data, we could write it as X train also, since it belongs to training data. In training data, we also know the category, right? The category of my entity, or the output, the particular outcome. So I am going to have another table or another column or another array in which I will be having the category. So for example, in fruit example, since I had 100, in this example, this container fruit example, I had 100 fruits. So in my X train matrix or in X train table, I will be having how many rows? I will be having 100 rows, right? There are 100 rows and 2 columns, 100 cross. So the size of my array is going to be 100 cross 2. And in Y, and there is going to be a matrix or an array in which I will be storing the true category of my fruits or the true category of my image. So in case of fruit, the Y array, it could be holding values like A, B, like this. And in case of an image, this Y matrix or array, it could be holding values like 0, 1, and 2, 3, 0 to 9, right? Because we have digits ranging from 0 to 9. Alright. So this is something, so this training data is given to us. So when a training data is given to us, so what is being given? We are given the X train and we are given the Y train, meaning this column. Okay. So for to make the prediction, what I am going to need X train, I will be given Y train, and I will be given the features of the new test point, right? I will be given the features of new test point. So for example, if I have 2 features, then this test point could be, for example, like here in this part, if I have 2 examples like here, so if I just do x train zero, if I try to access the zeroth element of my x train, then I will get a row, right? And in this row, I will be having two elements, right? Some value say 0.5 or 7.1, two values. Similarly, if it was, if I had say 28 features, 28 columns in this, so if I had done x train zero, then how many values I will be having inside one entity? I will be having 28 elements, right? So now 2D example, for a 2D example, the test point is going to look something like say 2.3 comma say 3, right? Something like this. Similarly, for three dimensional, it could be something like this, and the element keep on increasing as the number of features or the number of columns inside my X train data keeps on increasing, right? So these are the three things, and what else I will be needing? I will also be needing the value of k which I am choosing, right? So let's keep k at 3 for now. But we are just checking out the category of three closest neighbors, and based on that, we are going to predict the category of our new test point. So the first thing we are going to do is predict the, compute the distance, right? How we are going to predict that one point is closer to the another? How we are going to find our nearest neighbors? So we are going to find our nearest neighbor by computing the distance between the two. For example, if in a 2D space, if my test point was a 2D space, so this was point A and this was point B, and point B has a coordinates something x2 y2, and A had coordinates x1 y1, right? So the distance between the two will decide the closeness. So if the distance is they are closer, the distance will be small, and if they are large, if distance value is large, it means they lie far apart from each other, right? So how do we measure distance between 2 points? It is nothing but x1 using the Euclidean distance, right? You must have seen it. X1 minus x2 का whole square plus y1 minus y2 का whole square and under root. Similarly, if my if my input had say, or these points were in 3D, they had three dimensions. So I will have another z1 minus z2 kind of another term which was z1. And what if you had n dimensions? What if I had n number of columns in my X train data? Then my one entity will have n number of components, right? So in that case, the distance formula reduces to, I can write it something like this. Say my this is x1. This is my some input x. There are n number of components in it, x3, x4, up to xn, right? And if I want to, compute the distance, so I can simply say the two vectors is nothing but x and xa and xb, right? So I can say here that xa I minus xb I a whole square, and then I'm just summing it over like this. So if I just expand this, so it is this is summation. Summation means this looks something like this: xa1 minus xb1 whole square plus xa2 minus xb2 whole square plus up to xn xan minus xbn whole square. And then we do the under root, right? So this is the compact form of writing the same. So the first thing we need to do is find out the distance of my test point from the rest of the point in my training data, right? So to calculate the distance, first I need to subtract each of the components element wise, right? This is what I need to do. So if I just take, let's take a point like this. Since this is a vectorized in NumPy, I can do like I saw in this example, right? One example. If you just come back here and see, I have another vector which is B, right? So if I think of this A as some sample point or some point in my training data, and I think of this B array as my test point, right? So to compute the distance between these 2 points, what I can do, I can say, first of all, I need to subtract their element A minus B, right? I need to do, let's also make, let me print A and B. So this is how my A and B looks. This is my A and this is my B, okay? And now, to compute the distance, first I need to do the subtraction, right? Element-wise subtraction, like this, right? So what I can write? I can simply write A minus B. If you just do A minus B or B minus A, you can do both. It doesn't matter because eventually we are taking square, right? So if I do A minus B, you can see that there is element-wise subtraction, right? After this subtraction, what we have to do? We have to do the squaring, right? And as I said earlier, to square we use the double star operator, right? Not square to raise to any power. So this is the exponent. So this double star is for exponentiation. So I could also write 3, right? So if I just do square, you can see now we have the square terms with us. After taking square, what we have to do, if you can look carefully here. So after taking square of, after subtracting, then taking square, what we have to do, the summation of each of the elements, right? That I have obtained 1, I have 4, I have 9, I have 16 and 25. Now I need to sum these elements. So to sum, we have a function. This is sum function, and it takes the axis. Axis means if this is your 2D NumPy array, if this is your 2D NumPy array, so NumPy allows us to sum across 2 directions for a 2D case. That either I can, sum in this direction, like sum the columns, or either I can sum the rows. So this is axis 0, axis or direction 0, and when I'm going from left to right, this is axis 1. Since my test point and one row corresponds to one entity, right? Second row corresponds to second entity. So rows corresponds to entity, and I have to find the distance of my test point from every entity in my training data, right? So when I'm saying that I need to sum the elements, I need to sum these. I need to sum across which direction? I need to sum across the direction, this, across axis 1. So here I can, just provide axis V1. And after that, once I have taken the summation, after summation, I am just simply taking the root, right? Once summation has been done, I can take the root. For square root is nothing but, raised to power 1 by 2, right? So, raised to power 0.5, 1 by 2 minus 0.5, right? So I just write this, you will see that the distance between the array, in this particular case, the distance between the array A and B will reduce, will be given by this. If there is some error. Okay, this is not axis, but I axis. Okay, it is saying that it has just one dimension because these are 1D array, right? These are 1D array, right? In case of 2D array, we will need to have. So, for example, if my A array had been something like this, 1, 2, 3, 4, 5, right? It means there are two entities in my array A, right? Two examples. So, if I do this, okay, there is some type error. Here, okay. Since it's a 2D array, so I need to pack it. Right? So you can see that I have received, after computing the distance of my test point B, from two data points in my array A, I am receiving two values, right? Which is 7.4 and 7.4. Right? Similarly, in this case, my A array is nothing but X string. So if I just change or update the A variable here with X string, and I said that my B variable is nothing but test point, right? This will give me the distance of my test point from each of the entity in my training data. Okay, so this value is nothing but distance. Now, based on the distance, what I need to do, I need to compute the k nearest neighbors, right? Get the k nearest neighbor. Nearest neighbor, which will be the ones. So the entities which have the whose distance has the smallest value. So if I just sort this distance array, right? If I just sort this distance array and like this. So in the distance, what I have, this distance looks something like this. So D1, is nothing but the distance between my data point 1 in training data and the test point. D2 is the distance between entity 2 and my test point. D3 is the distance between entity 3 in training data and my test point, and so on. Right? Similarly, Dn. Now I'm saying let's just sort this distance. And I'm going to sort it in such a manner that what is going to give me. So if when I sort these values, let's say um, P5 has the smallest distance and D9 has then comes D9. So sorting means I'm just arranging it in ascending order, right? Then we have D11 or say we have D100 and so on. And in the end, the D20 has the largest value. Let's assume, right? Once I have sorted this, what I need, if I need to find out the k nearest neighbors, I really it the index, like which is the sample, which is the entity, which has the least distance. So I just need to pick the first k out of this, right? First k points, and of those first k points, I need to remember that this number, that corresponding to which entity in training data, the distance value is less, right? So I need to remember these indexes, corresponding indexes, right? It is very important because if I'm going to sort it according to the distance value, then I'm going to lose, the correspondence between the entity number, the entity index in the training data, right? So I need something jokey, but what it should do, it should straight away give me it indexes, it sorts the array based on on the distance value. But what it gives me, it gives me the corresponding index of the entity. So this is achieved in NumPy using a function which is argsort. So what argsort function does, let me show you. There is a function np.argsort. Sorting is clear. So for example, if I just give it a list like 5, 4, 3, 2, 1. So normal sort function, what will it do? A normal sort function will give you a sort 1, 2, 3, 4, 5, right? So if a normal sort function will give you 1, 2, 3, 4, 5. But the arg sort gives you the index of the shortest element. So for example, in this, the smallest element is 1. So index of that one here is 4, right? So what I am going to be getting is 4, 3, 2, 1, 0. So if I just run it, you will see the argsort gives the index corresponding to the smallest value. Not just the smallest value, but after sorting, you will be getting your elements something like this. Simple sort, not argsort. This is simple sort. Normal sort, you will be getting 1, 2, 3, 4, 5. But argsort, what it is giving you, it is giving you the index of your elements in the original array. So in the original array, my index of 1 was 4. In the original array, index of 2 was 1. Index of 2 was 3, right? So I get the index, corresponding index. So what I'm gonna get is the KNN index means index of the k nearest neighbors. I'm going to find it using the argsort function. I'm simply going to pass my distance array, right? I'm going to sort my distance array, and I do not need the entire, distance array. I just need the k indices, right? So, for example, if this is my d, if this had been my distance array, d is equal to control b, and I just need if I just wanted 3 elements, so I can simply say p3, right? So this is known as slicing. You can slice your array like this, right? Once you have got the indexes of your nearest neighbors, what you just need to know their category, right? So I now need the category of my nearest neighbors. I can get the category. Where do I have the category? In the byte range, right? The true category of my entities is stored in byte range. In byte range, inside byte range, I can just pass the indexes which have. Okay. So for example, if I come back to this D, and if I just pass a list of indexes, so say if I pass 0 and I pass 2, and if I just run this, okay, so this is a list. I first need to make it an array. Okay. So you can see that when I pass a list of indexes within my NumPy array, what it gives me, it just gives me the elements corresponding to the indices that have been passed. So if I want to get the category corresponding to the indices. Indices meaning KNN indexes. So I just need to pass it here. Then what is remaining? Now I have the categories of the nearest neighbors. I just need to find the majority, right? So there is this. Now I just need to find the count of that, as I was saying here now, that once you have the k nearest neighbors, what we were doing, we need to count the number of samples. We need to count the number of samples corresponding to each category. We need to count the number of samples corresponding to each category, right? So this is also again achieved. There is this function, count of samples. This is again achieved using there is numpy function which is np dot unique, right? And inside it you need to find you need to pass your array. So we are going to pass our KNN category array, right? And we also there is this return counts parameter argument in this function which we need to set true because we also need the count corresponding to each category, right? So uh, let's just also print these variables. So CLS is nothing but class, right? Class means category and the corresponding count. Okay. After this, once we have the count corresponding to each category, what we need to do, we just need to find the maximum value, right? So get the we just need to get the category with maximum count of samples. This is the majority vote, right? This is the answer of the majority, right? So to find the max, we are again going to be using a numpy function. So let's just there is this function which is np dot arg max. So what we are going to do, say for example, in the class array, say we have 0, 1, 2 categories, and in the count, say I had say k was equal to 10, so I got k nearest neighbors, right? 10 examples, and out of those 10 examples, the count of samples which will belong to 0, it was 7. Count of samples which belong to 1, it was 2. And count of sample which belong to category 2, it was 1. Right? So the value in CLS array and count array, what will it be? So it will be mapped by their indexes. So at the 0th index of count, I will be storing the count corresponding to category 0. So like I will be having 7 to 1. So let's just, so if I had say 7 examples here and 2 here, so you have 2, I would be having 2 and 7 here, right? So I need to map, because I'm going to get the maximum based on this, but what I really need is the category corresponding to the maximum, right? So the category corresponding to the maximum is 1. So for this I need the index, right? So again, we are going to be using a function called argmax. What this argmax function does, it gives me the index of the maximum element. So in this particular example, the element answer will be 2. And right, so let's just argmax, and I'm going to pass my count uh, array here. So once I have the count index of the maximum index corresponding to the maximum value, what will be my predicted class, predicted category or class? What will it be? It will be simply CLS max index, right? What will be the confidence? With what confidence I can say that you know the confidence with which I can say, okay, this is the predicted class of my input. So I can simply whatever is the count, or the maximum index, the index, whatever is the value at the max index, I just need to simply divide it by 8, right? For example, in this example here, the maximum count is 7. So if I have to give the confidence with which I can predict yes, this input has a category 1, I will simply divide it by 10. Right? 10 is nothing but k. Yeah, so we are just going to print this stuff. Let's just display it, right? And let's just print that predicted class. Predicted class is, and I'm also gonna print the confidence. Right? So this is my function, right? And now let's just look at the data, the handwritten digit data. So the handwritten to be load the MNIST, right? It is known as MNIST. So to load it, we need to load it. It is this function MNIST dot load data. And lab shows you, what it returns. So it returns a tuple of numpy arrays. So this is what it is going to return. So I'm simply going to, you know, copy it from here. Okay. So your training data is in X-train and the corresponding category to the entities of is stored in bytestring. Okay. So this is your data. Let's just look at the size of your X-train dot shape and Y-train dot shape. You can see that it has 60,000 input images, and all those images are 28 cross 28 size. And since in an example we have studied that, but we learned that one row corresponds to one example, right? So each in digit wala example, what we have is a an image like this 0, 1, 2, right? And each of these image of 28 cross 28 size. 28 cross 28 means you can divide this image in a grid of 28 cross 28, and you will be having a corresponding array. So in this array, you will be having 28 columns and 28 rows, and each value is nothing but a represents each of this, square, think of it as a pixel, and we have the intensity, the color intensity, right? So in the image, what is happening is, for example, if it is a zero image, so this part is going to be black, 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 and rest of the image is going to be white, white, white. Yeah. So these are the features. In case of an image, the features are the pixel values, right? And as we had said in this example that the rows correspond to one input, right? But in our X-ray data, we saw that it has a 3D shape, right? It has something like this. So what we need to do, we need to flatten this 28 cross 28 array. So what we are going to do, corresponding to image 1, image 1 is a 28 cross 28, 28 cross in size, right? So what we are going to do, we are going to put the first column like this, first row of 28 cross 28. Then we will have row 2. We will basically flatten our array. Okay? And similarly, you will do for row number 28. Right? So this is known as flattening. So first, visualize how our images look like. To see our input, we can, use this IM show function, which is in the 5 plot packet, 5 plot module. And inside this, we can simply pass xstring. Say I want to see the zeroth element or the zeroth image in my xstring. So if I just run this, so you can see it is of a 5, right? Similarly, if I write x test here, you can see that it is of a 7. Similarly, if I want to see what is the first image is of 2, right? So let's just test our function which we have written here, predict the function. So inside this predict function, right, we are passing our x train, we are giving our y train, then we are giving, uh, there is some noise as someone unmuted. Why there is all right. Uh, So say I just want to test the just let's just give our predict function the zero, right? We know that x test zero. What is the input image at x test zero? It is of 7. So let's just see what our model predicts if everything is right. Okay, so we have make some kind of mistake. Okay, so predicted का यहाँ spelling predicted. Now let's run it again. So you can see that my model का जो मेरे जो model का prediction है, it is something wrong, right? It has a wrong prediction. It is saying that why it is a wrong prediction? Corresponding to, it is saying that the class should be 1 because we have 18 samples of this. Let me, we have set k is equal to 3. We have the k in here. I think we just made some mistake in here. Extreme minus test point. So somewhere maybe 3. We run it on x test plus 0. X test के 0 के लिए we have a wrong prediction. Let's check out x test 1. Oh, okay. As I said that we need to, reshape, right? So we cannot really, we cannot pass it like this. We need to reshape it. Dot reshape. Reshape by reshaping, I'm simply flattening the input images into a 1D array. Right? So if I now run this, Okay, let us look at the shape of white rain. So white rain has 60,000. Yeah, that is right. So I just need to pass. Yeah, this is fine. Yes. Facial culture. Sure. Yeah. So let's just. I need to. I also needed to reshape my test point. So that's why it is getting there. This should work fine now. And since I have already reshaped my X string, I need not do it again. Here. So it is saying that 1 and 3. So X test 0, X test 1. What is X test 1? If I see here, X test 1 is an of 2, is 2. And so it is showing that predicted classes. I think I'm making some sort of error in writing the code maybe. It's maybe increase RK. Okay, guys, I think there is some sort of error here. Maybe I made some mistake. But I hope you understood, how KNN algorithm works. Let me, try to find out the nearest neighbors. I will check out the error because it's already 9:30. Ah, yes, ma'am. Yeah, so what we expected is that if the image is of 2, then I also expected 9. And my result should be predicted class should also be 2 here. And with maximum confidence, right? This is what we had wanted. Anyways, I will rectify the error maybe.
Can you please give us that code on LinkedIn?
On LinkedIn, I will share it.
I will share with the company.
Okay, just a minute. I will share it on my GitHub. My GitHub, I have. But I can share this with you, right? This collab.
Yeah.
Thanks. Let me know if you can access it.
Okay.
Where is the chat?
Okay, ma'am.
देख लो खोल के Is there any question?
No, it's not giving me access.
Maybe I will upload it here. I will upload it. So you can just check out I have
it up.
For the workshop, I have this CB work. I will give the link of the repository where I'm going to upload this video. So you'll find it here.
Thank you, ma'am. It was a great session.
I hope I was able to finish it in time. I was expecting, but
it's okay. No problem. Yeah. So many people left because of time only.
Yeah.
Yeah, we get a glimpse of how the machine learning thing algorithms and something like that.
Yeah, maybe I should have. Okay, thank you.
It's okay. No problem.
Yeah, thank you, guys.
Thank you, ma'am.
Thank you.
Okay.
We had a great session. Thank you.
Thanks a lot.
Good night, ma'am.